Alrighty, let's go. Class?
Yes.
Alright, so I apologize. My voice is horrible today. So now, I'm going to make sure that everyone is following along and paying attention. So we have everyone doing what they got to do, right? Alright, so for here, we're on example 5. This is page 11 in our notes. We're hopefully going to be able to finish up these today. So for this right here, it says an example, an application involving a function notation. Continue. So we have a function here, and this is the function. All of that right there. Models a car required stopping distance of f of x in feet on dry pavement traveling at x miles per hour. Use the function to find the required stopping distance at 60 miles per hour. So what I'm going to do is 60 miles per hour. 60 miles per hour. Is that going to be the distance or my speed?
Speed.
That's my speed, right? That's my speed. So 60 miles per hour, that's going to go in for my x value. That's not going to be the value that I'm getting out of it, because that's the distance in feet is what I'm getting out of it. So the amount that I'm putting in is going to be 60. So we're going to write this. So I'm going to write it in function notation and show you what to put in the calculator. So it's the function evaluating at 60 is 0.0875 parentheses 60 close square minus 0.4 parentheses 60 plus 6.6. Now, a lot of people were making a mistake the other day when we were trying to plug these into the calculator. Do you write f of x in your calculator? Say no. No, you don't write the f of x in the calculator. This is all you write. You start with the numerical part, just right there. This is all you're putting into the calculator right now. So I would like to see everyone right now actually plugging these in as soon as you're done writing it down. Did you get it? Okay, good. All right, so in my calculator, it's going to look like this. I have 0.08, what was my numbers? 75, right? Parentheses, 60 close square, minus, parentheses, 60, close,
66.6.
like that, right?
Yes.
All right, let's go ahead and plug it in the calculator. So my answer should come up with 357.6. So I'm hoping everyone actually got that. Is that what you got? No.
The parentheses, I didn't get that. Get back.
No, you got a plus sign right there. That's supposed to be a minus, isn't it?
Yeah.
Okay. So 357.6. What are my units? Hey, you guys, I'm starting to lose my voice again, so I need you guys paying attention. So, what are the units on this? What is it we're talking about that we got out? We put in 60 miles per hour. It's gonna be feet, right? Remember, this is a stopping distance problem. So this is feet. So I could read through it, it says round to the nearest foot. So if I'm rounding to the nearest foot, this is less than a foot, isn't it? That's less than a foot. So I'm gonna round to nearest foot. That means the whole number. Now, is 6, 5, or above? Yes, it is. So that means it's gonna make the 7 round up. If it was 4 below, those numbers just drop off. So this is gonna be F of 60 is gonna be about 358 feet. So here's what I had the answer in the first place, and my approximate symbol is when I round, I use my approximate symbol to say it's approximately that answer now. So a lot of people had trouble with the rounding on that last test. All right, questions? Not bad, right? Not too bad? Example 6. Now it says graph the function, these two together in the same rectangular coordinate system. Select integers from -2 to 2 inclusive. All right. So first thing I'm going to do is I'm going to do my first one, and then I'm going to do the second one. So my integers for my first one, so this is going to be my f of x. So let's start plugging in. So if this is going to be f of -2 is going to be 2 times -2, f of -1 So you guys are calculating for me, right? We're plugging this stuff in.
Yeah, you wrote one.
I wrote one. Oh, dang it. Thank you. There you go. All right, I'm going to fill these in. So now this is going to be
Negative what?
-4,
Negative 4.
-2, 0, 2, and 4, right? So make sure you weren't adding those together, because if you put the minus sign, you will change it up. Okay, negative is different than the minus sign. The minus sign is next to the decimal point. So we got those ones. Now we're going to do the next one. Okay, let me see. Insert page. So my other function was 2x plus 4. And then we're going to do all right. Now we're going to do this one, doing the same things. Do the same steps right here on this. Right, same steps, same steps. You can do that one here, because it's this right here. That's the G of X. See, because I had to make a new page, because you have to do the whole point. Okay, so that was that one right there, and this was G of X. I'll do that right there. That's this one, but give me the other one. This is a different one. So I'll start with the G. Just put them in that part. So 2. No, the 2 first. Parentheses. -2. Close. There we go. Now plus 4. There we go. That's your first one. And then keep going. Did you get it? Where'd you write it? Good. Did you get it? Good job. Yeah, make it a lot easier. I asked Jay to actually pass out paper before, and he kind of forgot you too. Maybe because some people forgot to put earbuds in. Why do you think it's always about you? It's you! It's you! Yeah, it's not put your hair back over it, it's take them out. Alright, let's see what we got. So, we got, for my answers, I should have 0. What's the next one? 2. Next one. Next one.
8.
Like that? You guys agree? All right, and my other one was -4, -2, 0, 2, 4. Okay. And we're going to go and graph these, and I'm going to show you how to graph these next. With those 5 points, we're going to graph. Let me go here. So insert page after current. So now I'm on my scratch pad. Let's please take a look because this is going to be important on the scratch pad. So you could do this 2 different ways. One way, it's right up here on the top. See next to the calculator, there's a little graph thingy there. You can click there, or you hit the scratch pad button one more time, and it's going to give you a graph. So you could plug in your f of x. So my f of x on this problem was it 2x?
No, 2x is 4.
That was my first one, right? The first one is just 2x. So there's my first line. Now I need to enter the second line. So this is important. I know you all paying attention. To enter a second line, you hit the tab button. Tab is right below the scratch pad. Hit tab, and then you could, if you notice it says F2, that means a second function. So instead of calling it F2 in our equation that we have for your problem, we called it another name. We called it G of x. But F2 means the same thing. It just means a second function. So this was 2x plus 4, right there, right? And look at these. Pretty lines here, right? Is anyone having trouble getting theirs on a graph to work? No one? Alright, let me see. And so our graph will go right here in my notes for the presentation. Now, does anyone need help getting their graph to actually look like mine? There's your second one. Now we'll go back to fix your first one. So tab, so let's see, you have an extra x right here. So let's go and get rid of that. Now it should just do it like that. There we go. So now it's there. So now so you can actually see it. Use your mouse, grab it. Like I did. Okay? Thanks, Rick. Alright, anyone else still getting there? X plus 4. There you go. Now you have them both. Anyone else? Huh? Oh, okay, just hold it and then move it. So if you notice the hand, sometimes it takes longer to move it, okay? You just get the hand close on it. Anyone else struggling? Mars, you struggling? Because I don't see it on your calculator. That's what I'm worried about right now. Mars. Calculator's good. It's a toy. You should be like super excited. It's like better than a fidget spinner. Hey, got the second one, first one. Oh, no, you don't have that one. So now, right, 2x. 2x. And piece. Sí, look, es muy bien. Watch. Mira, mira, mira. We good? Yep. Good. All right. So we have these on here already, so we were able to actually do this with our calculator this time, because you guys are going to need some graphs paper for some of this other stuff that we're doing. Now, can you tell me the relationship in between these two? I know you did these in geometry. I know you did. Do you know why? I taught this stuff when you guys were in geometry. What type of lines are these? They are parallel. They are parallel lines. Parallel lines, by definition, have the same slope. Okay, same slope. Now, in this one right here, it's also but different y-intercept. Have same slope but different y-intercept. So here my slope is 2x and slope is 2x. So the number in front of the x is your slope. We're going to get to that here in a second. Vertical line tests. If any vertical line test for function, if any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. Now, a vertical line. What does a vertical line look like? That's horizontal. Straight up and down is vertical. So I'm looking at this and I'm asking the question, can I draw a vertical line anywhere on A and it cross my line more than once? Can I? Straight up and down. Antonio says yes. Other people say no. Like right there? So is it crossing more than once? So this right here you're saying is not a function. So that's not a function. You are absolutely correct. So if you could draw a line on it, anywhere on it that you could cross the line more than once and cross that function more than once, it's not going to be a function. B, can I draw a vertical line somewhere on here and it crossed more than once? No. So that means this one is a function. C. No, it's not a function, or yes. It is a function. I can't cross it more than once, right? So there's nowhere I could draw a vertical line. So this one also is a function. And then let's look at D. So on D, if I draw a vertical line on D, okay, I could draw it right about here, right? Okay, I could draw it right here. If you notice, it does cross more than once, doesn't it? So this one is not a function. Not a function, right? So I'm hoping everyone is actually writing these down for each one, because that's super important, right? right, questions, concern, complaints about that?
Can you go back to example 6?
Example 6? Right here?
Yeah.
Okay. What else do we have? We have this example 8. Alright, I'm gonna pause video and then go back to this. Alright, so listen up. I'm gonna pause the video here. I'm gonna give you guys some time to start working on your practice. And then we're gonna come back and finish up example 8 here in a moment. So I'm gonna pause this here. You guys already know your homework problems you're supposed to start doing, right? Alright, now I got your attention. Let's try this. Class. Alright, example 8, last problem. So this is reading a graph. For those people that are following along, paying attention, we're reading from the graph. Given the graph illustrates the body temperature from 8 a.m. through 3 p.m., let X be the number of hours after 8 a.m., Y be the body temperature at time X. So, at 0 hours, if you read this, at 0 hours, what time is that? At 0 hours, what time is it? 8 a.m. It says right here, let X be the number of hours after 8 a.m. So 0 represents 8 a.m. No, I'm trying to teach class here. Go. All right, so what is the temperature at 8 a.m.? Looking at the graph. What is the temperature at 8 a.m.? 101. So average temperature at 8 a.m. is 101. Wait, hold on. There it is, right there. Oh, dang it, back. There we go. All right, so this one is degrees, and that's Fahrenheit. Why do I know it's Fahrenheit? Okay, it says on the side. What do you know about 100 degrees Celsius? Huh? What happens at 100 degrees Celsius? Water boils at 100 degrees Celsius. So, remember, okay, Celsius and Fahrenheit are two different things. So 100 degrees Celsius is water boiling. 101 degrees Fahrenheit is a slightly elevated temperature for you, normal body temperature. Now, during which period of time is your temperature decreasing? When is it going down? When is the graph going down? It's 3 hours, but now it's asking for an interval. Period of time. So when does it start decreasing? It starts where? It starts at 0, right? It starts at 0, so it's going to look like this. It's going to start at 0. And it's decreasing until what point? So all this right here is decreasing. Next one. Estimate your minimum temperature during the time period. Estimate the minimum temperature. What do you think the minimum temperature is?
8.5.
Say the whole thing.
8.5 Fahrenheit.
Say the whole thing. You're getting really close. 98.5. Yes, you had it. Okay? 98.5. 98.5. How many hours after 8 a.m. does it reach that? How many hours after 8 a.m. does that occur? It's 3 hours past that, right? So right here, 3 hours past that is going to be a minimum. But what is 3 hours past 8 a.m.? Yeah, it is at 11 a.m. So it's at 11 a.m. for that one. So we're just picking stuff off the graph for these things. During which time period is your temperature increasing?
3 to 5.
From 3 to 5, right? It starts here at 3 and it increases till 5. So just so you know, this is interval notation. So it's not the same as a coordinate pair. It's saying it's going from 3 to 5 here. So that was this one right here. E, part of the graph is shown as a horizontal line segment. What does that mean about your temperature, and when does this occur?
This temperature stays the same throughout the hours.
Perfect. Your temperature stays the same. Your temperature stays the same. But what do we know about the temperature staying the same? Your temperature stays the same starting when? 5. Okay. 5 hours after 8 a.m. So what do you think that would be though? At 1 p.m. It stays same. Now, if you guys notice, you guys have places to write this down in your notes where I don't, so that's why I'm writing on the slide. You don't have to write on the slide. Now, this last one, part F, explain why the graph defines y as a function of x. Is this the function? Right here, is it a function? I'm looking for vertical lines, right? Is it a function? Yes, it is. It is a function. Okay, and as we progress through the day, your temperature is going to go up and down through this. So it is a function. As we progress through the day, your temperature goes up and down. Keep going up and down. All right, so for you guys to know, here is another way. So what I did is I copied these, like specifically the wording on this, so you could see what the wording's supposed to be for this. So C, D, and there we go. So you have everything you need there. All right. So don't forget, like, share, and subscribe. Hit that notification button and buy stuff from my merch store. Support my channel.
No.
No. No. You're a hater.